Alright guys, the last chapter of calculus is dealing with derivatives and antiderivatives, so we got to go back and forth, so it might get a little bit tricky, of natural logarithms, exponents, exponential equations, and different things like that. So we need to learn some properties before we can do derivatives of natural logarithms, and those properties are that if the natural logarithm of 1, it will equal 0. The natural logarithm of taking two numbers multiplied together, you can write it as two separate logarithms, so you can split it apart. If you have a natural logarithm of something to an exponent, you can move that exponent out in front. If you have a natural logarithm of two things being divided, you can write it, separate them, and put a subtraction sign in between them. So let's try some examples of using our properties. So here, we have the natural logarithm of 2 divided by 3. So we want to expand it. So we're going to write the natural logarithm of 2 minus the natural logarithm of 3. The reason I chose the operation of subtraction was because they were being divided. So see if you can do this one on your own. It has the natural logarithm of xy divided by z. So we got the natural logarithm of x plus the natural logarithm of y, because it was multiplying there, minus the natural logarithm of z. Notice between each operation symbol you have to write the natural log. So here, let's see if you can do these ones on your own. I would rewrite this as the natural log of a squared plus 1 to the 1/3. So I would move the exponent out in front, the 1/3, and so I have the natural logarithm of a squared plus 1. That squared cannot go out in front because this whole quantity here is not squared, it's just the a, so you can't move it. Alright, for this one, I would say the natural log of x squared minus 1 is going to be to the 3rd power, so I'm going to move that 3 out in front, minus the natural log of x cubed, and that 3 also belongs there, so I have to move the 3 out there. This one can be broken down further for extra credit, and that would be the natural log, 3 natural log of x plus 1 plus 3 natural log of x minus 1. And what I did was I factored this here. So if they're being multiplied, you add them. This cube can move out in front, and when it does, it becomes 9 ln x. See if you can do this bottom one on your own. So we have ln z plus 2 ln of z minus 1. And you're done. Oh, wrong one. All right. From here, we're going to write it as a single quantity. So we're only going to write ln once. Here we have subtraction between our two ln's. So that means we're going to have division of the first one divided by the second one. And you're done. To see if you can do this one, it's a little bit more complicated, but we can do it. So we have this 3rd, and that's for everything. So I'm going to have a quantity to the 3rd power. Here we got 2 ln x plus 3. So we have x plus 3 squared, because of the 2. You have plus ln x. So since it says plus, are you going to divide or are you going to multiply? You should say multiply, so times x. Here we have minus ln of x squared minus 1. So you can divide, since it's minus, x squared minus 1. If you want extra credit, you could split that apart down there. So try this last one on your own. You should say ln of stuff to the 3 halves. That stuff is going to be x squared plus 1 divided by x plus 1 and x minus 1. Those were both being subtracted, so we put them underneath the division bar. Alright, so now actually to the calculus. If we want to find the derivative of ln x, its derivative is x prime over x. And I'm going to write this as y equals ln u. Some people it confuses when it has the x there. So the derivative would be the derivative of u over u. Means the same thing, I just used a different letter because sometimes when you use x, people don't get it. So let's do some examples. Here we have y equals ln of x squared. Every time that you have the natural log and you want to find the derivative, you must rewrite it first before you find derivative. So we're going to rewrite this using our properties as 2 ln of x. The 2 got moved in front because it was an exponent. So do your derivative of ln x. Well, we just wrote that it was u prime over u. So the derivative of x is 1 over x. So we have 2 times that. So I wrote it as 2 over x. I simplified a little bit. And there's my derivative. So see if you can do this one on your own. Well, you can't rewrite because it's all to the fourth. It's not just the x to the fourth. So we can rewrite it as u to the fourth power, u being ln x. Well, we just realized that the derivative of ln x is 1 over x. Derivative of u to the fourth is 4u cubed. So let's put them together. We got 4u is ln x cubed times 1 over x. And there's your derivative. If you want, you can put this portion all divided by x and combine it and make it a fraction. So, see if you can do this one on your own by rewriting first. So we rewrite as ln x plus a half ln x squared minus 1. So derivative of ln x is 1 over x. Derivative here, we got plus a half. Our u is x squared minus 1. So our derivative is 2x. So for ln, you put your derivative on top, divided by your u. Oh, minus 1. There you go. So let's simplify this because it's being multiplied. You would get x over x squared minus 1 because the 2's would cancel. Now, some of you might have rewrote this part as x plus 1, x minus 1, and that is fine as well. Your answer will be a little bit different than mine. So here we have ln of x divided by x squared plus 1. See if you can do this on your own. Rewrite, so it's not going to be a derivative just yet. So rewrite, and you get ln x plus ln x squared plus 1. And some of you are like, plus, lady, it's division. So you got to subtract. If you try to move that squared out, you can't because it only belongs to the x. It doesn't belong to the whole quantity. So we're going to do the derivative. We already said the derivative of ln x is 1 over x minus. Here we have u is x squared plus 1. So derivative is 2x. So that goes on top over your u, and you're done. Yeah, you go again. So here we got ln t divided by t squared. Well, the t is with the ln, but the t squared's not. So you can't rewrite. You have t in the top and t in the bottom, so you must do the quotient rule. So low is t squared, high is ln t. Derivative of the low is 2t. Derivative of the high is 1 over t. Cross them. You get t minus 2t ln t. ln works like sine and cosine. You can't put it in there and combine it. The bottom squared, so t squared squared, is t to the fourth. Some of you might realize that every term has a t in common, so it can simplify to t, how about 1, because if you take a t out, 1 minus 2 ln t over t cubed. Yay, go you. So here we got ln of ln x squared. So, can't rewrite, but we can say y equals ln u, where u is ln of x squared. So u is 2 ln x, which its derivative is 2 times 1 over x, which is 2 over x. Crazy, huh? You can say that here, your derivative of ln u is 1 over u. So we have 1 over u, which is ln x squared, times 2 over x. So you can combine, multiply across, so 2 over, I'm going to put that x in front. I'm not going to make it x cubed, because you can't bring it in there. And there you go. So, try this one on your own. Rewrite as a half ln x plus 1 minus a half ln x minus 1. Derivative is a half times 1 over x plus 1, because the derivative of x plus 1 is 1 over the original, minus a half times 1 over x minus 1. This one is x minus 1, so its derivative is 1 over that. Multiply across, so you get 1 over 2x plus 2 minus 1 over 2x minus 2. If you don't want to distribute on the bottom, you don't have to, but I went ahead and did because it was baby. So, do this one. Rewrite. So, ln a half 4 plus x squared minus ln x. We have a half times, derivative of this is 2x over 4 plus x squared minus, derivative of this is 1 over x. So you get x over 4 plus x squared minus 1 over x. On these problems, if you do not rewrite first, you will get them counted wrong. So make sure that you rewrite first. And that is it for notes. Please come with questions over this for next time.